Okay, section 9.5, factoring special products. So with these, I'm just going to point out a few special products that might help you so you don't have to go through the whole factoring process that we did in the last section. So if you can recognize these two special types, that might make your life a little bit easier. So we have two different special types of products. We have the difference of two squares, okay, which is exactly like what it sounds like. It's a difference because it's a subtraction problem. And then you have two perfect squares. So to factor a difference of two squares, basically if you have a squared minus b squared, when you factor it, it's a plus b, a minus b. Okay. And then the perfect square trinomials is when you have a number squared on either side, and then you have twice the product of the two numbers. So in that case, it'll be a plus b, or a plus b squared. Or if you have that minus 2ab, then it would be minus, or a minus b squared. Okay, and it's confusing with letters, but when you see it with numbers, it'll make a lot more sense. So a few examples, okay? The first one we have an example, it's a difference of two squares. There's only two terms, so that's a difference of two squares. And if we look up here, we basically take the square root of each one, and then it's a plus b and a minus b. So if I take the square root of x, or x squared, that's just going to give me x. And the square root of 9 is 3. So it ends up being x plus 3, x minus 3. And if you want to multiply that all out to make sure it works, you'll see that you get x squared minus 9 again. Now this one, we have a squared is x. Okay, so a is x, b is 16, and then 2ab. So the square root of x squared is just x. Square root of 16 is 4. So let me do x plus 4, or x plus 4 squared. And if you take a look, it is 2 times ab, because a is x, b is 4, and if we take 2 times 4x, that gives us 8x. Same idea here, but the only difference is that it's minus 8x. So the only difference in my answer is I'm going to be subtracting 4, or x minus 4 squared. Okay. So we're going to do a few more examples so you can see how to recognize these. To recognize the difference of two squares, look for the coefficients that are perfect squares and for the variables that are raised to the second power. So you need to have two things. You need to have a variable raised to a second power, which all three of these examples do. And then all your numbers need to be perfect squares, which if we look in all these examples, 4, 25, and 49, all of them are perfect squares. So when you have difference of squares, basically we have x squared minus, what's the square root of 4? It's 2. So my factored form is x minus 2, x plus 2. Or x plus 2, x minus 2. So you basically take the square root of them, and then it's one of the factors is plus, one of the factors is minus. So what we have here is we have 4x squared. So what's the square root of 4? That's going to give me 2. And then we have minus 25. Well, what's the square root of 25? That's 5. Okay, so we have a difference of two squares. So when we write our factored form, it's 2x plus 5 and 2x minus 5. And then one more time. What's the square root of 25? That's 5. Minus, what's the square root of 49? That's 7, and then we have the x squared. So when we write our factored form, 5 plus 7x, 5 minus 7x. So take a minute and try to factor these on your own. Okay. Part B, to recognize a perfect square trinomial, the first and last terms must be positive perfect squares. Okay, they have to be positive. It's not a difference of squares. The first and last term are going to be positive. And the middle term must be twice the product of A and B. Okay. So if we look at this one, we have the first term is x squared. That's perfect square. The last term is 4. 4 is a perfect square. What is the square root of 4? That's actually going to give me 2, which it looks like. Okay, the square root of 4 is 2, and since it's minus 4 here, it's x minus 2. And x minus 2, so x minus 2 squared. And that's all you're doing is taking the square roots of the first term and the last term. Okay. All right, so this one, we have 16y squared. 16 is a perfect square. We have 9. 9 is a perfect square. What's the square root of 16, and what's the square root of 9? Square root of 16 is 4, square root of 9 is 3. And since it's plus in the middle there, it's x plus 3. 4x plus 3. And if you double check, it needs to be twice the product of a and b. If we do a times b, 4 times 3, that gives me 12. And the middle term is 2 times 12, 24. Let's do one more. So the first term's a perfect square, the last term's a perfect square. Let's take the square root of each of those. So what's the square root of 9 and 25? That's going to give me 3 and 5. And since it's minus in the middle, 3t minus 5, 3t minus 5. And then let's just double check if we do a times b. 3 times negative 5 is negative 15. Middle term is twice negative 15, negative 30. Now, if you don't like this, you can go ahead and do what we did in the last section. I'm just trying to give you some shortcuts here so you can save yourself some work. The last part, though, this is something I do actually want you to do. This will make your life a whole lot easier. Before doing any factoring in any of these, see if you can factor out a GCF. Okay, so in this first one, we have 3x squared and 27. We can factor out a GCF of 3. And when we factor out a GCF of 3, divide them both by 3, that's x squared minus 9. That's going to make our lives a whole lot easier now, because now we can clearly see a difference of squares. Okay, what's the square root of 9? It's going to give me 3, so x plus 3, x minus 3. So before you do any factoring, just double check that there's not a GCF. So in B, is there a GCF? Is there something I can divide all 3 of these by? Yeah, I can divide them all by 3, so I can factor out a GCF of 3. And if I divide everything by 3, 3 divided by 3 is 1. Negative 30 divided by 3 is negative 10. And 75 divided by 3 is 25. And then I have a perfect square trinomial, because I have a perfect square in the front, perfect square in the back. Okay, take the square root of each of them. Square root of x squared is x, square root of 25 is 5, and since it's minus 10x, you have minus 5. X minus 5, x minus 5. And then if you do 1 times negative 5, that's negative 5. Twice negative 5 is negative 10. All right, C, what can I factor out? This one has a GCF. What can I divide all of those by in C? I can divide all of them by 4y. Okay, and then since I took out a variable, all the exponents decreased by 1, and I divided everything by 4. And now look at this, I have another perfect square trinomial. Okay, 4 and 25. Okay, take the square root of each of those. So I have 4y, 2y plus 5, and 2y minus 5. And if I do 2 times 5, that gives me 10. 20 is twice 10. One more. Do you see a GCF? Yeah, our GCF would be 2. And then once again, perfect square in the front, perfect square in the back. Just take the square root of each of them. Okay. And we get x plus 4, because the square root of 16 is 4. And remember, the 2 is out front. We're going to skip E, but we'll work on factoring more in class. So if you have any questions, just feel free to jot them down and ask them in class when we go over all this.